All right, listener. Are you ready for a deep dive today? We're going to take a look at the race for a COVID-19 vaccine
Oh, yeah.
using Gregory Zuckerman's book, A Shot to Save the World.
Yeah. This book it's fascinating because you get all these different perspectives,
It's amazing.
from scientists to executives to government officials, so you get a very well-rounded view of what happened.
Absolutely. And I
Yeah.
think one of the most interesting things Zuckerman does is he takes us all the way back to the 1980s with the AIDS crisis to really set the stage.
Right, because,
Or the
there are so many parallels.
Yeah.
You have a global pandemic, you have this immense fear, and that really sets the tone for the urgency that permeates the whole book. And one of the scientists he talks to, Dr. Edmund Tremont, he describes having to treat a general with AIDS
Oh, wow.
at Walter Reed Army Medical Center at 4 a.m.
Wow.
just to protect the general's privacy.
That's dedication. And it also shows you how stigmatized the disease was
Absolutely.
back then.
And HIV is, it's a retrovirus, which
Right.
means it integrates itself into the host's DNA, making it incredibly difficult to target. Scientists hit a lot of dead ends,
Right.
and it really created this despair in the research community.
It makes you appreciate how far we've come with vaccines
It does.
in general.
Absolutely.
Like, Jonas Salk and the polio vaccine, for example.
Yeah, and the book mentions how Salk was reading Darwin during a sermon
I love that little detail.
as a kid.
Yeah,
Yeah, it's fascinating, those little humanizing details.
it really is.
But it shows, that these scientists weren't afraid to think differently, to
Right.
challenge conventions, and that kind of thinking leads to breakthroughs.
Yeah, absolutely.
Yeah.
So I guess maybe before we go too far, let's do a real quick refresher on how vaccines work.
Right.
Just so we're all on the same page.
So it's basically like a training exercise for your immune system,
Okay.
a simulation, almost like a
Yeah.
simulated battle. You introduce a weakened or inactive version of a pathogen, so it could be a virus or a bacteria,
Right.
and this allows your body to learn to recognize and fight it.
Got it.
So when the real deal comes along, your immune system is ready to go.
It's a pretty ingenious strategy when you think about it.
It is. It's brilliant, and it saved countless lives.
So now let's talk about some of the early pioneers of mRNA technology.
Okay.
One name that comes up is Gail Smith, who had a very unconventional path to science.
Yeah.
High school dropout.
That's right.
Ended up developing a method to produce proteins using insect cells.
It's incredible. He even got to present his work to Jonas Salk and Albert Sabin.
Wow, talk about pressure.
Talk about pressure. But, you see this pattern throughout history. Groundbreaking discoveries often come from people who don't necessarily follow the traditional track.
Right. Makes you wonder how many brilliant minds we're overlooking
Absolutely.
because they don't fit the mold.
Totally. And while Smith's work wasn't directly related to mRNA vaccines, it laid some of the groundwork
Right.
for future innovations in that field.
Interesting.
And another key figure is Eli Gilboa,
Mm-hmm.
who was a huge advocate for mRNA technology, even when a lot of people were skeptical.
He was really ahead of his time, wasn't he?
He really saw the potential for mRNA in treating diseases like cancer.
So he was already thinking about training the immune system
Yeah.
to fight disease.
Yeah, absolutely.
So why was there so much resistance to mRNA back then?
Well, it was a new technology,
Right.
and there were a lot of hurdles to overcome.
Like what kind of hurdles?
One of the biggest was delivery.
Okay.
mRNA is a delicate molecule, and it's easily degraded. So scientists were struggling to find an effective way to get it into cells without it breaking down.
Got it.
And then there was also the issue of immune response.
Okay.
Early attempts at using mRNA often triggered a really strong inflammatory reaction.
So it's hard to use therapeutically.
Exactly. So
Yeah.
despite its potential, it was seen as a pretty risky bet.
But that didn't deter everyone, right? Like Katalin Karikó.
Yes, Katalin Karikó, she is really a remarkable figure.
She is.
Talk about perseverance.
Incredible.
She faced so many setbacks, financial hardship, demotion. Her supervisor actually called her research destructive,
Wow.
but she never gave up.
That's incredible.
She was convinced that mRNA had the potential to revolutionize medicine.
And she was right.
And her breakthrough in stabilizing mRNA was absolutely crucial. She figured out a way to modify the molecule so it wouldn't trigger such a strong inflammatory response.
So that basically made mRNA technology viable for vaccines.
Exactly. And it's incredible to think that her research, which was once dismissed,
Right.
played such a key role in the fight against COVID-19.
It just goes to show that scientific progress isn't always a straight line.
Yeah.
Sometimes the most groundbreaking discoveries come from those who are willing to stick with their ideas.
Absolutely.
even when everybody else doubts them. And that kind of persistence is what led to the rise of Moderna, this company that would become a major player in the COVID-19 vaccine race.
Yeah, their story is a whirlwind,
It really is.
filled with ambition and secrecy and even internal conflict.
Yeah.
But it all starts with a scientist named Derek Rossi, who, like some of the others we've talked about, also had a pretty unconventional background.
I'm sensing a theme here.
Yes, definitely.
So Rossi wasn't even initially focused on vaccines.
Right.
He was exploring the potential of mRNA technology for stem cell research.
Yeah, completely different application.
Yeah.
But his work caught the attention of Robert Langer, this prominent MIT scientist and entrepreneur, and that collaboration really gave legitimacy to this new technology.
And that seems to be a recurring theme, too.
Yeah.
The convergence of different disciplines.
Yeah, absolutely.
Leading to these groundbreaking advancements.
That's right.
And then you've got Nubora Fan,
Right.
venture capitalists with a knack for spotting disruptive technologies.
Yeah, he saw the potential of mRNA, and he really spearheaded the founding of Moderna.
Took a leap of faith.
It was a huge leap of faith, but he was willing to bet on this unproven technology.
And that leap of faith ultimately led to the creation of a company that would help save millions of lives.
Yeah, it's pretty incredible.
It's a remarkable story.
Yeah, it is.
But Moderna's early days were not easy.
Oh, no, they were definitely not a smooth ride.
They faced a lot of challenges.
Yeah, a lot of challenges. I mean, secrecy was a big one.
Okay.
They operated in stealth mode, which caused a lot of tension within the company. And it also made it really hard to attract talent.
Yeah, I could see how that would be a problem.
And then there were the scientific hurdles.
Okay.
Things like transient protein expression, which meant that the proteins produced by the mRNA weren't lasting long enough to be effective.
That's a big problem.
It was a huge problem, and they were constantly battling for funding.
So they were really on the brink of collapse several times.
There were, yeah, several times.
So we have this company, Moderna, with this potentially revolutionary technology, but they're facing all these challenges, and then, boom, COVID-19 hits.
The world changes overnight.
And that's where we'll pick up next time on part 2 of this deep dive into a shot to save the world.
Yeah, this is where it gets really interesting. So last time we left off with Moderna facing all these challenges, right? The secrecy, the funding issues, those scientific roadblocks they were facing, and then suddenly COVID-19 hits and throws the entire world into a panic.
Talk about a high-pressure situation.
Well, yeah, it's like a scene out of a movie, everyone's scrambling, trying to figure out what this virus is, how does it spread, how do we stop it?
And in all that chaos, you really see the best of humanity coming out, I think.
Oh, yeah, absolutely.
The collaboration, the ingenuity that drive to solve this global crisis.
It's really inspiring.
So where does the actual race for a vaccine begin?
It starts with this scientist in China, Ken Zhang.
Okay.
He's the one who sequences the entire genome of the COVID-19 virus.
Oh.
Now imagine the pressure he was under. I mean, he knew that this information was critical for developing a vaccine. But he also faced this huge ethical dilemma in terms of sharing it with the rest of the world.
Yeah, I bet there were a lot of political pressures, too.
Oh, I'm sure. But ultimately, he decided to collaborate with Edward Holmes, this Australian scientist.
Okay.
And together, they released the genetic sequence to the global scientific community.
Wow, so that one act of collaboration really set the stage for everything that followed.
Oh, it was a pivotal moment. I mean, without that information, the vaccine race wouldn't have even been possible.
Yeah, absolutely. So now you have the virus's genetic code out there.
Yeah.
And scientists around the world can start working on vaccines.
Right, and two really key figures in this early stage were Barney Graham and Jason McClellan. Both specialists in coronavirus research. And they had actually already been working on stabilizing the spike protein, which is a crucial part of a vaccine, long before the pandemic even hit.
So they were kind of ahead of the game in a way.
Oh, yeah, definitely. I mean, they had this foundation of knowledge that they could build on. They had been studying other coronaviruses like MERS. And that research gave them this blueprint for understanding how these viruses work and how to target them with vaccines.
So it's like their previous research, which might have seemed obscure at the time, suddenly became incredibly relevant.
Absolutely. You never know when a seemingly unrelated line of research might suddenly become critical.
It really shows you that scientific progress is often unpredictable.
Oh, for sure.
But they weren't the only ones working on that spike protein, right?
Right.
There was also Nianshuang Wang, a scientist in China, who was also trying to stabilize its structure.
Yes, and his story is fascinating. He talks a lot about imposter syndrome and the anxiety he faced.
Oh, wow.
I mean, he was brilliant, but he still had those doubts,
Right.
But he pushed through, driven by this desire to make a difference. And his work was actually crucial in developing the COVID-19 vaccines.
It's a good reminder that, even the most brilliant minds, they're still human. They still have doubts and insecurities just like the rest of us.
Right. It's a good reminder that anyone can achieve amazing things, if they have the passion and the perseverance.
That's a great point. So we've been talking about this spike protein, but there's another crucial piece of the puzzle, right?
Yeah.
The delivery system. How do you actually get the vaccine into the body and make it work?
That's where the unsung heroes of the vaccine race come in.
Oh, are they?
The scientists working on these lipid nanoparticles.
Okay, what are those?
They're also called LNPs.
Okay.
Basically, they're tiny bubbles of fat that protect the mRNA and help it get inside our cells.
Oh, wow.
Without LNPs, the mRNA wouldn't stand a chance.
So they're like microscopic delivery trucks.
Exactly, taking that precious cargo, the mRNA, to where it needs to go.
Moderna had a team led by Hamilton Bennett, who was working on those LNPs.
Right, and they were constantly tweaking and refining that formula, trying to make it as effective and as safe as possible.
I remember reading about some serendipitous moments along the way, too.
Oh, yes, like when Melissa Moore, another Moderna scientist, accidentally discovered that a simple chemical compound could dramatically improve how well those LNPs worked.
Wow, talk about a lucky break.
Right. She wasn't even trying to find a solution to that specific problem, but her accidental discovery ended up being a total game changer.
That's amazing. So you have Moderna with this promising mRNA technology, a refined delivery system, and a team of brilliant scientists working around the clock.
Right.
But they weren't the only ones in this race.
Oh, definitely not. You had Pfizer, who partnered with BioNTech, a German company, to develop their own mRNA vaccine.
Right.
You had Oxford AstraZeneca, who were using this different approach called an adenovirus vector vaccine. And Johnson & Johnson, who were working on yet another type of vaccine using a protein subunit approach.
Wow. So this is a truly global effort.
Yes.
With each team bringing their own unique expertise and technology to the table.
Absolutely.
It was a race on a scale we've never seen before.
It was.
And I can only imagine the pressure.
The pressure was immense. The whole world was watching, waiting for any sign of hope.
And the speed at which everything was happening was unprecedented.
Right. Governments were pouring money into vaccine development. Regulatory agencies were fast-tracking approvals.
I remember those early days of the pandemic. Every news report was just filled with anxiety and uncertainty.
Right.
And then in the midst of all that darkness, we finally got a glimmer of hope. The first clinical trial results started coming out.
And the results were stunning.
What were they?
Pfizer-BioNTech announced that their mRNA vaccine had an efficacy rate of over 90%.
Wow.
It was a watershed moment. Suddenly, there was this realistic chance of ending the pandemic.
I bet the scientists were ecstatic.
Oh, absolutely. I mean, years of research, countless setbacks, and then finally this incredible breakthrough. And it wasn't just Pfizer-BioNTech. Moderna also announced their results shortly after.
What was theirs?
An even higher efficacy rate, 94.5% for their mRNA vaccine.
It was a huge validation for Moderna.
Absolutely, years of research.
And for mRNA technology in general.
Absolutely.
But not every team had such resounding success, right?
Right.
Oxford AstraZeneca had a bit of a bumpier road.
Yeah, they did. They faced those dosing errors early on.
Right.
And their vaccine ended up having a lower efficacy rate than the mRNA vaccines. Plus, they faced a lot of public skepticism, which made the rollout more complicated.
Yeah, I remember the concerns about those rare blood clotting events linked to their vaccine.
That was a major setback for them.
Right.
But it's important to remember that even with those challenges, the Oxford AstraZeneca vaccine still played a really important role in the global fight against the pandemic.
Especially in countries with limited resources.
Absolutely.
It was a crucial tool.
And then there was Johnson & Johnson with their single-dose vaccine.
Right.
That seemed very promising, especially for hard-to-reach populations.
Yeah, the single-dose aspect was a huge advantage logistically.
Right.
But then they also ran into those setbacks with the blood clotting events.
It really highlights the inherent risks in any medical intervention, even vaccines. Absolutely. No matter how much you test things, there's always a chance of unforeseen side effects.
And then we had Novavax, the underdog of the vaccine race.
Right. They had a very promising protein subunit vaccine, but they really struggled to get funding and recognition. They were kind of overshadowed by the bigger players.
It's a classic underdog story.
It is, but it's also a testament to their persistence.
Right.
They never gave up, and they eventually succeeded in bringing their vaccine to market.
It's a good reminder that sometimes the underdog wins.
They proved that there's more than one way to develop an effective vaccine.
But even with all these incredible scientific achievements, the story of the COVID-19 pandemic doesn't end with vaccines, right?
Right. The book also delves into the long-term effects of the virus, long COVID.
Right. This is a really important aspect of the whole story.
It is. It's a complex condition. It can be really debilitating, and it affects a lot of people who've had the virus.
And we're still learning so much about it.
Absolutely. We're still trying to understand the causes and potential treatments.
Yeah, it's a reminder that this fight is far from over.
We still have a lot to learn.
One of the stories that really stuck with me was that of Jessamine Smith.
Oh, yeah.
She had these really debilitating long COVID symptoms.
Mm-hmm.
And then after she got vaccinated, she experienced significant relief.
It wasn't a cure, but it gave her back some semblance of a normal life.
It's a powerful story.
It really is.
Because it shows you the potential benefits of vaccination, even for those who've already had COVID.
Right, and it shows the ongoing scientific journey to understand and treat this really complex condition.
So it's clear that the development of vaccines was a monumental achievement.
Absolutely.
But it's also just one chapter in a much larger story.
Right.
And the pandemic really exposed so many vulnerabilities in our healthcare systems.
Oh, yeah.
And how prepared we are or aren't for future outbreaks.
It definitely highlighted those weaknesses.
And the book really drives home this point.
Right.
That we need to invest in public health infrastructure, foster global collaboration, build trust in scientific institutions.
Those are really important points.
It's a call to action for all of us.
It is.
We can't just rest on our laurels here.
You can't.
We need to learn from this experience.
Absolutely.
And be prepared for the next challenge.
And that's what's so great about this book.
With that?
It's not just a rehashing of past events.
Right.
It really is a launching point for a bigger conversation about the future of science, medicine, and global health.
It's incredible when you think about the scale of this whole operation.
Yeah.
We've talked about the scientific breakthroughs, the clinical trial results, but there's this whole other side to the story.
Right.
The logistics. How do you actually manufacture billions of doses of a brand new vaccine and distribute it around the world?
Right. It's mind-boggling.
It's a massive undertaking.
And a book really highlights those challenges, the behind-the-scenes stuff that most people don't even think about.
Like that story about Juan Andres, the Moderna executive.
Oh, yeah.
Who bought that huge industrial freezer
before
they even had the funding secured.
He just had a gut feeling they would need it.
And he was right.
And it shows just how high the stakes were. Yeah. Everyone operating in this uncertain environment, making decisions on the fly, taking risks.
And it's amazing that they managed to pull it off.
It really is.
But it wasn't always perfect.
No, definitely not.
I mean, there were some missteps along the way.
There were like some of the communication issues that some companies had, like when Moderna initially released only partial data from their trials.
Right.
That created a lot of confusion and backlash.
And then there were the dosing discrepancies with the Oxford-AstraZeneca vaccine.
Right.
Which raised questions about its efficacy.
Yeah, those incidents highlight how important transparency and communication are, especially during a public health crisis.
Absolutely. You need to build trust.
Exactly.
And it wasn't just about communicating the science effectively. There were also all these ethical considerations to grapple with.
Oh, definitely.
Who should get the vaccine first? How do we ensure that everyone has access globally?
Those are really tough questions.
And the book doesn't shy away from those tough questions.
No, it doesn't.
It really delves into the complexities.
It does.
The role of profit, the potential for disparities.
These are really important conversations that we need to be having as a society.
Okay, so we have these vaccines. We're starting to roll them out.
Right.
But the story doesn't end there.
It doesn't.
This virus is still out there.
It is.
Mutating, new variants are emerging.
Right. And then you have the whole issue of vaccine hesitancy.
It's like a constant game of cat and mouse.
Yeah, it really is. And the book makes it clear that the fight against COVID-19 is far from over. This is an evolving situation.
Right.
And we need to be prepared to adapt.
I mean, the emergence of Delta and Omicron really threw a wrench in the works.
They really did. And they raised all these new questions, about the durability of immunity, the need for boosters.
It just added another layer of complexity to the whole thing.
Exactly.
But I think it's important to remember that science is a process.
It is.
It's not a destination.
It's a journey.
And we're constantly learning and adapting as we go.
And the pandemic really accelerated scientific innovation in so many ways.
Look at mRNA technology.
Yeah.
It's not just about vaccines anymore.
It's true.
It has the potential to revolutionize how we treat so many diseases.
Absolutely.
From cancer to genetic disorders, it's incredible.
It really is like a whole new world has opened up.
And that's one of the key takeaways from this book.
It is.
For all the devastation and loss that this pandemic brought, it also spurred all this incredible scientific progress.
It did.
And now it's up to us to build on that momentum.
Absolutely.
So what does all this mean for you, listener?
That's the big question, isn't it?
We've explored the science, the human stories, the triumphs, the setbacks of this vaccine race, and Zuckerman leaves us with this really thought-provoking question.
What have we learned?
What have we learned?
And how can we use those lessons to be better prepared for the future?
It's a call to action.
It is.
Stay informed, engage in these conversations, support scientific research, advocate for policies that prioritize public health and global cooperation. We all have a role to play in building a healthier and more resilient future.
We do.
Well said. And on that note, we wrap up our deep dive into A Shot to Save the World.
It's an incredible story.
It is a story of scientific brilliance, human resilience, and the power of collaboration.
It shows what we can achieve when we work together.
Absolutely, even in the face of incredible adversity.
Even in the darkest of times, there's always hope.
And the possibility of a brighter future.